Hello, I'm Haihan from the Visualization Design Lab at the University of Utah. Today, I'll be talking about our work, Data Hunches, incorporating personal knowledge into visualizations. Let's start with this New York Times visualization on COVID cases in Utah. In 2021 holiday season, they denoted data anomaly. However, that was not the case for the 2020 holiday season. In this chart, we see that there are two dips in the case count near Thanksgiving and Christmas. However, this is likely due to reporting agencies not reporting during the holiday season, probably not an actual dip in case numbers. And we have seen similar things in our lab's work with domain experts. For example, in our work Sanguine, we designed and implemented the visualization interface for analyzing transfusion data in hospital settings. When we presented the interface to surgeons, they had doubt about the data that the visualizations showed. The visualization showed them low blood recycling usage. However, based on their experience, they would always turn on the machine for blood recycling. Hence, they suspected that they were missing charting when the volume of blood recycling was low. Another work done in our group recorded similar encounter when we designed a visualization application for experts studying Zika outbreaks. We noticed that different experts have knowledge about the imperfections of the Zika cases reporting. For example, one country only reports cases of Zika in pregnant women detected within the first trimester. Another country reported all confirmed and suspected cases as confirmed cases. Or a country doesn't report any cases because their union goes on strike often. These knowledge are implicit when the experts are viewing the visualization, yet they heavily impact on how they interpreted the visualization and the data behind. And our visualizations were effective to implicitly show the personal knowledges or to be used to communicate the knowledge to others. These were just the two examples we have reported in publications, but we have seen many similar cases in our collaborations and conversations with domain experts, so we want to put a name on this. In this work, we define data hunches as an analyst's knowledge about how and why the data is an imperfect and partial representation of the phenomenon of interest. Data hunches have been prevalent and important, but often implicit. It impacts how data is perceived and is as important as data when it comes to describing phenomena of interest. We formalize data hunches in our work so that we can emphasize the important role that personal knowledge plays in data analysis. With us putting a term to actually describe the personal knowledge, we can start to think about how we can explicitly record and communicate data hunches. With the design exploration, analysts can use our proposed techniques to communicate their data hunches intuitively with colleagues. How are data hunches currently communicated? We have annotations, such as New York Times denoting that many states did not report data on Memorial Day. There are lab notebooks to record data caveats, which are often get translated into the methods section in a paper to communicate these data caveats. Or only verbally communicate them? Or do we just not even talk about them at all? These existing methods provide very limited ability to externalize data hunches explicitly, and it is hard to communicate and share them effectively and intuitively. With all the rich research in interactive data visualizations, we think we can do a lot more to record data hunches. We begin to brainstorm how we can explicitly show data hunches in an intuitive way with visualizations. We think that data hunches can be recorded in any chart. For example, in a line chart where a user can draw their data hunch. In a network, adding a node and edges or indicating an edge that should be removed. In a bar chart, indicating a different value higher than the original visualization. Or in a map where a user can express different categorical color filling. But different charts can vary in difficulty when implementing data hunches in it. For our work, we decide to focus on bar chart. To explore how data hunches can be recorded and communicated, we built a prototype where users can record data hunches with the techniques proposed in our paper. Here we show recording a value hunch through direct manipulation. We can select a bar and choose from a range of possible techniques to record a data hunch. Direct manipulations allow users to drag a bar for sizes, then input their reasoning and confidence for the data hunch. So let's quickly step through what type of data hunches are recorded in our prototype. To start with, the assessment hunch speaks to the quality or trustworthiness of the data. For example, a user may give a data a high rating as they consider the data collection trustworthy. Structural hunches speak to the inclusion and exclusion of data items. For example, a user wants to exclude not applicable in this dataset about CS student majors and add it to unknown category. And finally, we identify value hunches. A user may think that the reality of France's COVID cases is between 700 and 1400 instead. Or that New Zealand might have COVID cases around 3,000 instead of 2,800. We can see how data hunches can be recorded and communicated in our prototype here. We have a bar chart of student research area distribution in an institution. One faculty reviewed the distribution and made the comment, "The database is classified as data and visualization, but I think it should be in computer systems." With our prototype, they can actually record this value hunch in the chart directly. Then they also see that robotics looks smaller than what I think it should be. Maybe some students are classified as AI incorrectly. So they can record a range for students in robotics based on their data hunch and adjust the AI area students accordingly. After reviewing the student distribution and recording their data hunches, they show their recordings to a fellow faculty. To review the data hunch, the second faculty can see the reasoning behind the data hunch by hovering on it and upvote it if they agree with the data hunch. We have recordings of data hunches in the visualization and upvote for them. And now they can pass the visualization with the data hunches along to other faculties to review. From our literature research and the iterative design process for the prototype, we generalized our lessons learned into these guidelines for designing for data hunches. When considering other techniques that were not mentioned or implemented, the techniques should fulfill most of the design principles here. We will go through a few here since time is limited. First off is never change the original data. Techniques for data hunches are used to express knowledge about the data, not a tool to alter the dataset. Data hunches are another layer of information added on top. There should be a clear difference between data and data hunches to avoid confusion and retain the integrity of data. Also, from a technical aspect, the data hunches should be recorded as a separate dataset. It helps with further analysis of data hunches and can be used to track along with data evolution. Second, make data hunches distinct. This is consistent with do not change data. Data hunches should be clearly distinguishable in the visualizations and give the intuition that this is clearly not the same as the original visualizations. In our prototype, we opt for sketching rendering and handwritten fonts to distinguish from the original visualizations. Using the sketchiness also emphasizes the human factors in data hunches. But at the same time, make data hunches similar in terms of visual encodings. Similar visual encodings can help with the comparison with the original data and between data hunches. It makes reading data hunches a lot easier without the need for the mental conversion. Reasoning and context is critical to support the validity of data hunch. Therefore, in the prototype, we require all data hunches to be accompanied with the reasoning so that a reader can understand the data hunch fully. We also recommend recording author's identity to establish trust. We hope to open up new design opportunities by recognizing data hunches and proposing techniques to record them, but there are some issues and ethical considerations we need to address. We identify 3 main challenges and concerns that can come along with data hunches. We have detailed discussions in our paper, and I will only go into the first point here. Does the data hunch reinforce user biases? Ideally, we think data hunches can provide rich knowledge to understanding of data and reality, and that all parties involved are positively contributing based on the knowledge and the understanding. However, there is a possibility of data hunches being used to explain away inconvenient data points or reinforce analysts' preconceived ideas. We think that requiring explanation and justification can help other readers to evaluate data hunches holistically, but this remains an open question to be investigated. This is only the first step to formally recognize how much personal knowledge plays in interpreting visualizations. We only explore the tip of the iceberg. We wonder how we can bring data hunches into a variety of visualizations and contexts. Or what about bringing data hunches into design studies? Second, we, as a community, should recognize and value the role of personal knowledge in data analysis. It can be challenging, but our research community should start considering how to incorporate data hunches in analysis tools and designs. The prototype of data hunches is available at this URL, and thank you for listening.